Number 1 and number 2 are very similar. And when you take your test, one of them you can continue factoring, one of them you cannot. So let's look at number 1. We have a difference of two squares. So the square root of x to the 4th is x squared. The square root of 49 is going to be 7. So from this part we have x squared plus 7 and x squared minus 7. Let's look at the second factor. We have a minus, but we don't have a difference of two squares because square root of 7 is a decimal. So this is our answer. But contrast that with number 2. Number 2, the square root of x squared, x to the 4th is x squared. The square root of 16 is going to be 4. So we have x squared plus 4 and x squared minus 4. But the second factor, the x squared minus 4, we can continue factoring with that because the square root of 4 is 2. So we have x plus 2, x minus 2. This all came from this part. And then the first factor, the x squared plus 4, don't forget to copy it down. This is part of the answer. So here we have 3 factors. Same thing for number 3 and 4 on your test. You will see one that you can continue factoring and one that you cannot. So let's take a look at number 3. So number 3, we have a trinomial. We have 3 terms. So we will do the cross multiply method. So let's break up 4. We can try 2 times 2 and 3 times 3. So that will give us a 6 and a 6, but there's no way to get a negative 5 with a 6, with 2 6s. So we can try maybe 1 and 4 and 3 and 3. So a 3 and 12, and that still does not work. So we can try 1 and 4 and 1 and 9. Cross multiply, 1 times 9 is 9. 4 times 1 is 4. To get a negative 5, let's do a negative 9, positive 4, positive and negative. And double checking, positive 1 times negative 9 is a negative 9. So from this work, we can write the factors now. So our factors are going to be x squared plus 1. And the reason why it's x squared is because we have exponent 4 here. And 4x squared minus 9. Now looking at these factors, notice that the second factor, the 4x squared minus 9, we have a difference of 2 squares because the square root of 4 is 2 and the square root of 9 is 3. So make sure you recognize that. So this gives you 2x plus 3 and 2x minus 3. And then the first factor that we can't do anything, we cannot factor that one. So let's just copy that down. So x squared plus 1. So your final answer is going to be all 3 of these factors together. Now look at number 4. So let's break up the 3. So that's 1 times 3. Let's break up the 20. So what can we do here? We can try 4 times 5. So 1 times 5 is 5. 3 times 4 is 12. Okay, can't get an 11 with that. So let's try flipping it. 1 and 3, 5 and 4. So 1 times 4 is 4. 3 times 5 is going to be 15. So we have a positive 1, positive 15 and negative 4. Positive, negative over here. And so that works. And so our factors are going to be x squared plus 5 and 3x squared minus 4. But looking at this, the x squared plus 5, there's nothing we can do with that because the square root of, first of all, this is a plus, so we don't even have this difference of 2 squares. But for the second one, there's no square root of 3. The square root of 3 is a decimal. So there's nothing we can do. That's our final answer. But on number 3, you see how we can break one of these factors up further by factoring the difference of 2 squares. For number 5, we are multiplying 2 rational expression. So make sure you understand the only time we need the same denominator, the same bottom, is when you're adding or subtracting rational expressions. Right now we're multiplying. The denominator, it does not matter if they're the same or different. The key to this is to underline all the different factors we have. So factors are things that are just multiplied with each other. So here we have a 3 multiply with the x, multiply with x minus 8, multiply with the 2x plus 5, and a 1. At the bottom we have x, multiply with x plus 2. And then look at this 2x plus 5. This is one single factor. Now what you want to do is look for factors that are same top and bottom, so they can divide out to be 1. So we have the 2x plus 5 on the top and 2x plus 5 on the bottom. What else do we have? This part, a lot of students have been missing this. We have the x on top and an x on the bottom. So make sure you understand that 3x are two different factors. We have a 3 and we have an x. So the x's can cancel out. Now, your answer is just going to be whatever's left over. So on the top, we have a 3. We have an x minus 8. We also have a 1, but when you multiply by 1, nothing changes, so we don't need to put up times 1. Well, 3 times 1 is 3. On the bottom, the only thing left over is the x plus 2, and that's your final answer. In number 6, we are dividing two rational expressions. So when you're dividing, what you want to do is you want to flip, you want to invert the second fraction. So we'll make it upside down. So we have n squared on top plus 10n plus 24. On the bottom, we have a 5n minus 30. So I'm going to cross this out so I won't accidentally look at this again. Okay, so first of all, we need to factor here. So we have 1 and 1, 24. Let's try 6 times 4. So we have 4 and 6 to get a positive 10. They both need to be positive. Positive and positive. So that gives you n plus 6 and n plus 4 on the top. So let's scratch this out. In the bottom part, see how we have the 5n minus 30? That's a GCF. What can we divide both of those by? We can divide them by a 5. So 5n divided by 5 leaves you with n, and negative 30 divided by 5 leaves you with negative 6. So cross this out. Okay, now that we have factored everything that we can, let's see which factors are the same top and bottom that we can just divide out to be 1. So we have an n plus 6 on the top, and we have an n plus 6 here on the bottom, and looks like that's it. So what's left over on the top, we have a 1, but remember 1 times anything doesn't change anything. So on the top, all we have is the n plus 4. On the bottom, we have the 5 multiply with n minus 6. And here is our final answer. Number 7 and 8 are similar, that they both have the same denominator. So we don't have to worry about getting a common denominator. So for number 7, we simply combine like terms. So let's get all the n's together. So there we go. That's all we have. So we just have an n by itself right here. So put that down. And then for the constants, we have 3 minus 1, which is positive 2, n plus 2. On the bottom, the common denominator, we have 2n squared minus 10n. That's the answer. And for number 8, when you're subtracting two rational expressions, that's the same thing as going over here and flipping the sign. So this positive r becomes a negative r, and negative 6 becomes a positive 6. So same thing like we did on number 7, because the denominators are the same. Don't have to worry about that. 4 minus, this is a 1. 4 minus 1 is 3r plus 6. And on the bottom, we have 10r squared plus 18r minus 36. So that's the answer. So for the key for number 8 is actually for both numbers 7 and 8. So be careful when you're subtracting. Do not forget to change the signs. In number 9, we are adding two fractions, but they have different denominators. So when you have different denominators, we need to count how many different factors, how many unique factors we have. So here we have a 3. I'm going to put that down. We have a 3x plus 4. Put that down. And here we have a 3x plus 4, but we already have that. Now for each fraction, let's look at what we need to multiply by to get a common denominator. So the first fraction has a 3 and also has a 3x plus 4. It is not missing anything. But the second one, to make the denominator, the bottom, to look like the first fraction, we need to multiply by 3. So let's multiply this by 3. So here we have 2 times 3 is 6. Bring down the 4. 4 plus 6 is equal to 10. So our answer will be 10 over 3 times 3x plus 4. For number 10, the two rational expressions have different denominators. So we need, and since we are subtracting, we need to get the common denominator. Here we have a minus, so flip the sign, so that positive 2 will become a negative 2. We can factor this one, so that's a 1 times 1 and 2 times 5 to make a 10. 1 times 5 is 5, 1 times 2 is 2. Make the 5 positive and the 2 negative, negative positive. So here we have x minus 2 and x plus 5. I'm going to scratch this out. And so let's count the different types of factors that we have. Here we have an x minus 2. We have an x plus 5. And here we have another x plus 5, but we wrote that down already. So the first fraction already has both factors in the denominator. So the first fraction does not need to multiply by anything. But the second one needs the x minus 2. It already has the x plus 5, but it does not have the x minus 2. So let's distribute this. Okay, so that leaves you with, we have a 5 minus negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. So for the x, we have negative 2x. And here we have positive 5 plus 4 is positive 9.